Hello and welcome to Edisathi. Today we'll discuss the topic of binomial theorem. So let's get started. I hope all of you know what is x plus y whole square, which is x square plus y square plus 2xy. Likewise, you all must also be knowing what is x minus y whole square. It is x square plus y square minus 2xy. X plus y whole cube is given as x cube plus y cube plus 3x square y plus 3y square x, and x minus y whole cube would be given as x cube minus y cube minus 3x square y plus 3y square x. But what is the expansion of x plus y raised to power 4 or x minus y raised to power 7? What would you do in that case? Would you do x plus y into x plus y into x plus y into x plus y? That means, would you be solving this thing out? You can do that thing as well. That is an option that you guys have. So if you solve this thing, you'll get x square plus y square plus 2xy. So you'll be again multiplying x square plus y square plus 2xy, and again, can I write a whole square of that? You can solve this thing out. But what if it comes to raised to power 7, or for that purpose raised to power 10 or 15? It'll be very, very difficult for us to actually expand the things and get to our answer. Here, binomial thing come into picture. Binomial comes to rescue. This theorem helps us in calculating the power of any binomial. I hope you understand the meaning of the word binomial. Bi means two and nomial means term. So it is an expansion related to two terms. So x plus y raised to power n without actually multiplying out. So what I was doing here was actually multiplying out the things. Without actually multiplying out the things, what is the expansion of a binomial is what binomial theorem help us to find out. So let's understand binomial theorem. Binomial theorem is an algebraic expansion of powers of a binomial. So expansion of powers of a binomial. That means I'm talking till now about two terms here, and I'm expanding them. So it is something like x plus y raised to power n. It is also known as binomial expansion. So if I say binomial theorem or binomial expansion, it technically means one is the same thing. We expand the powers of x plus y raised to power n into a sum involving the terms of the form a, x raised to power b and y raised to power c. So what actually I am doing here is I am getting the terms of the form x raised to power b, y raised to power c. Now this b and c is what you actually have to determine with the coefficient which is a. And I am involving a sums. That means it's a summation of these terms with a, b and c varying. Where b and c, as I've already told you, are the exponents of x and y. One thing that you need to take into consideration is these are non-negative integers with b plus c always equal to n. Always. This is very, very important. b plus c is always equal to n. And the coefficient a of each term is a specific positive integer depending upon n and b. So a that I'm talking about has to be a positive integer. This b and c, which are the exponent, can be 0 or positive, because I'm talking about non-negative. Non-negative means it can be the case of 0 as well. So 0 or positive, and the condition that you have to specify is b plus c is equal to n. So the coefficient that you have determined, a, is known as the binomial coefficient. So this coefficient will be known as a binomial coefficient. We can find out this coefficient using the combinations formula. So this number gives the number of different combination of B elements that can be chosen from an L element set. What exactly is it? NCB or NCC, whatever you want to call it. We generally write it as NCR. Now look at it. Out of a n element set, I am choosing B elements at a time. That is the value of the coefficient that you will find out. It is NCR. Now, the coefficients that you get for varying value of n and b, they can be arranged to form a Pascal's triangle. And this is how a Pascal's triangle look like. So, the values of the integers in the Pascal triangle gives the coefficients of x plus y raised to power n. So if it is 0, it will be 1. The coefficient will be 1. For x plus y raised to power 1, if you expand it, it will be x plus y only. So the coefficient of x is 1. The coefficient of y is again 1. For x plus y whole squared, the coefficients would be given as x squared plus 2xy plus y squared. So it will be 1, 2 and 1. Similarly, for x plus y whole cube, the coefficients would be 1, 3, 3, 1. And for x plus y raised to power 4, it will be 1, 4, 6, 4, 1. For x plus y raised to power 5, it will be 1, 5, 10, 10, 5 and 1. So this will be the coefficients that you will have for each binomial term. So if you look at it, if it is raised to power 0, I have one term. If it is raised to power 1, I have actually two terms. If it is raised to power 2, I have three terms. If it is raised to power 3, there are four terms which are there. If it is raised to power 4, there are 5 terms. If it is raised to power 5, there are 6 terms. So a number which is x plus y raised to power n will have n plus 1 terms. The number of the terms in the expansion is of x plus y raised to power n is always one more than the exponent. Now let's look at the expansion for binomial. So if you have x plus y raised to power n, it will be written as nc0, which is the coefficient for the first term, x raised to power n, plus nc1, which is the coefficient for the second term, x raised to power n minus 1, y raised to power 1, plus nc2, x raised to power n minus 2, y raised to power 2, plus nc3, which is the coefficient for the fourth term, x raised to power n minus 3, y raised to power 3. It will go on till the time you have ncn, y raised to power n. So if you look at the terms, in each term, the sum of powers of x and y is always equal to n. N plus 2 plus 2, it is n. N minus 1 plus 1. N minus 3 plus 3. The sum of powers a, x raised to power b, y raised to power c. The sum of powers of b and c is always equal to n that you have. So it's similar to a thing like you have n chocolates to be divided into two people, such that the total number of chocolates with them will always be n. So what you will give? You will give first all the chocolates to to x, and y is left with none. Now, one by one, you will take one chocolate from x and give it to y. So x now has n minus 1, y has 1. Take one more from x, give it to y, minus 2 and plus 2. Take one more from x and give it to y. So y will now have 3 and x will have n minus 3. If you keep on doing so till the time all the chocolates of x have been given to y. So y will have n chocolates and x will have none of the chocolate now. So the number of terms that you will have will be n plus 1. N plus 1, 1 is for 0 chocolate, and 1, 2, 3, 4, so on up to n. For n chocolate, there are n options. So n plus 0 gives you n plus 1 terms in the expansion of x plus y raised to power n. So if I want to write the same theorem with the help of a sigma notation and factorial, the binomial theorem can be written as, now if you look at it, it is x plus y raised to power n would be written as summation of NCR x raised to power n minus r, y raised to power r. R will vary from 0 to n. So, I'll start with the value of r as 0. I will move up to till n. So, for the first term, the value of r would be 0. If you look here, all the chocolates are with n, y has none. If I further want to solve NCR, it will be the summation of r ranging from 0 to n. NCR is n factorial over n minus r factorial and r factorial into x raised to power n minus r and y raised to power r. That is the formula that you will have if you want to write the binomial theorem. So this is the general expansion for it. If you want to find out any specific term, find the value of r and you will get your term. So for example, I want the third term. Third term means the value of r would actually be 2. So it is written as tr plus 1. If I have to find r plus 1 term, it will be NCR x raised to power n minus r and y raised to power r. Because for the first term, the r value is 0. So for the third term, r value would be 2. It will be NC2 x raised to power n minus 2 and y raised to power 2. So I hope you can now write down the expansion for a binomial theorem. NC0, so on up to NCn, totaling of n plus 1 terms and the sum of binomial and the sum of exponents of the two variable x and y would always be equal to n. So the things that you need to note and remember in a binomial theorem is the powers of x will go down until it reaches 0. So the powers of x will start from n, it will go down till the time it reaches 0. Starting value is n and the ending value is 0 in x plus y raised to power n. The powers of y go the reverse way. The powers of y go up from 0. So they start from 0 until, this should be y raised to power 0. Yeah, this should be y raised to power 0 until it reaches n in the expansion of x plus y raised to power n. The nth row of a Pascal's triangle will be the coefficient of the expanded binomial thing. So if you remember the Pascal's triangle and if you can find out the nth row, nth means raised to the power. So if you need x plus y whole cube, I will look at the row of x plus y raised to power 3. The nth row of a Pascal's triangle will be the coefficients of the expanded binomial. However, we actually don't do Pascal triangle in actual, we just find out the value of NCR. The sum of exponents of each term is equal to n. So that is the same thing that we discussed. B plus C will always be equal to n that you have. In any term, the sum of the exponents will be equal to n plus 1. And you need to remember that the number of terms in the expansion of x plus y raised to power n will be equal to n plus 1. There's always one more term in the expansion of x plus y raised to power n. Now, let us look at some of the expansions. So, if you have x plus y raised to power 4, it will have 5 terms because the power is 4. So, it will start with 4c0, x raised to power 4, all the powers to x now. I'll take one power from x, give it to y. Take one more, give it to y. Take one more, give it to y. Take one more and give it to y. X has none. X is left with nothing and y has all the things. So you will go about like this and the coefficients will vary with 4c0, 4c1, 4c2, 4c3 and 4c4. So you will have 5 coefficients starting from 4c0 and ending with 4c4. if you just further solve the value of the coefficients for C1, I know NC1 is always equal to N, and NCN is also equal to N, and NCR is equal to NCN minus R. Also, NC0 is 1, if you remember this thing, and NCN is also 1. NCN minus 1 is equal to N. Yeah. So if I just put back the values, 4C0 would be 1, 4C1 would be 4, 4C2 I solve it out. For 6, 4C3 will be equal to 4C1 and 4C4 will be equal to 4C0. So it will be 4 that it will be y raised to power 4 that you will have. So all the factors are the combinations of x and y where the sum of exponents is always 4. X4, x cube y, x square y square, x y cube and y raised to power 4. You start with the highest power of x, take one, give it to y, take one more, give it to y, take one more, give it to y, take one more, give it to y, till the time x is left with nothing. So the degree of each term will be equal to 4. The first term is actually x raised to power 4, y raised to power 0. So anything raised to power 0 is written as 1. So we only take x raised to power 4 and we neglect y raised to power 0. The binomial coefficients that you would notice here are 1, 4, 6, 4, 1. If you notice, there is a symmetry that you have. First and the last are same, second and the second last are same. So the coefficients from left to right are the same as from right to left. So the value of NCR is equal to NCN minus R. The coefficients which are equidistant from the front and the back are equal in magnitude. And a very important thing that you need to understand is middle term will have the highest binomial coefficient. Binomial coefficients first increase, they reach to a maximum value, then they start decreasing. So the first and the last would be same, second and the second last, third and the third last, fourth and the fourth last, and the middle term will have the highest binomial coefficients. Let's look at another thing that we have. Now instead of a plus sign, we have minus sign. X minus y raised to power 5. Now whenever you have a case of x minus y, treat it as x plus minus y. So this will be treated as the second term, this will be treated as the first term with the plus sign. Therefore, each term will be of the form x raised to power n minus r and y raised to power r. So this minus sign will be taken into consideration whenever I am finding out any general term. So whenever your value of r is even, minus y raised to power r will turn out to be positive. But whenever this r is odd, it will turn out to be negative. So if you notice here, each odd power of y will have a minus sign and each even power of y will have a plus sign. So alternatively, we'll have plus and minus sign when we are expanding x minus y raised to power 5. Now next, plus 5 raised to power 5, there will be all plus signs and this is what the expansion look like. You start with 5c0, end with 5c5, give all the powers to x first, keep on taking one power and give all the powers to y in the end. But when you have x minus y, for all the odd powers of r, you will have a minus sign. So this is an odd power, you will have a minus sign. Odd power, you will have a minus sign. Odd power, you will have a minus sign. Alternatively, the terms will be plus, minus, plus, minus, plus and minus. So if you further solve down the values for 5c1, 5c2, 5c3, 5c4 and 5c5, you will get the expansion of x minus y raised to power 5 as x raised to power 5 minus 5 x4y plus 10 x cube y square minus 10 x square y cube plus 5 xy4 and minus y raised to power 5. There will be 6 terms because the value of n is 5. So there will be total of 6 terms that you have in the expansion of x minus y raised to power n. Another thing to note here is the symmetry. So the coefficients are same, the coefficients are same and the coefficients are same. Obviously there will be a difference of plus and the minus sign, but the value or the magnitude of the coefficients will turn out to be exactly the same. Now if you look here, there are 6 terms that you have. So you will have 2 middle terms, and the coefficient of both the middle terms would be same and would be the highest that you can ever attain in this expansion, which is coming out to be 10. Now, how to find out the middle term? Finding the middle term turns out to be important because the middle term has the highest value for the binomial coefficient. So for the binomial coefficient, middle term has the highest value. Now, if the value of n comes out to be even, that means there will be n plus 1 number of terms. That means the number of terms that you will have will be odd and you will have only one middle term. So if the value of n is 4, the number of terms are 5. So you will look at it that the third term is the middle term that you will have. You will have only one middle term, and that middle term will be t n by 2 plus 1. So if the value of n is 4, it will be t 4 by 2 plus 1, and that means it is the third term which will be the middle term that I will have. If the value of n is odd, that means you will have n plus 1, that means even number of terms. Whenever you have even number of terms, you will have 2 middle terms, and the coefficients of both the middle terms would be equal. Now both the middle terms would actually be the term which is n plus 1 by 2 and n plus 3 by 2. For example, we take n is equal to 9. So there are 10 terms that you have. The middle term would be fifth term, and the sixth term would be the middle term that you will have. So you can follow the formula n plus 1 by 2, which is 9 plus 1 by 2, 5, and 9 plus 3 by 2, which is 6. Fifth and the sixth term will be the middle term. 4 terms would be here, 1, 2, 3, 4, and 4 terms would be here, 7, 8, 9, 10. There will be 2 middle terms that you will have. So middle term has the highest binomial coefficient as already stated. Let's move ahead and let's look at some of the expansions. 1 plus x raised to power n. Now what is there? This is the first term, which is 1, and the second term which is there is x. So if I go ahead and write down the expansion, it will be nc0, 1 raised to power n. So 1 raised to power anything will always be equal to 1. So even if I don't write that term in the expansion, that is completely okay. Plus nc1, x raised to power 1, plus nc2, x square, plus nc3 x cube, plus nc4 x raised to power 4, plus nc5 x raised to power 5, and so on till the time it is ncn x raised to power n. So a general term would be given by ncr x raised to power r. Whatever is the r value, that will be the power of the x that you will have here. Similarly, if you have 1 minus x raised to power n, alternatively you will have plus and minus sign. The expansion would remain exactly the same. The only difference would become this minus sign. Whenever it is an odd power, you will have a minus sign. Whenever it is an even power, you will have a plus sign. So the last term, I don't know whether it is the value of n is odd or even. So I'll write it as minus 1 raised to power n, ncn x raised to power n. So any general term tr plus 1 would be given as ncr minus x raised to power r that you will have. So first term it will be nc0, and the value of r can vary from 0 to n, giving me n plus 1 terms. So if you look at it, now if you take both the equations that I have written and you add them and divide it with 2. Now when you add them, all the odd terms would get cancelled out. You will be left with 2 times the even terms. So if I take common 2, it will be adjusted here. It will be nc0 plus nc2 x square plus nc4 x raised to power 4 plus nc6 x raised to power 6, and so on. Similarly, if we subtract the 2 terms, you will look at all the even terms would get cancelled out and we'll be left with twice the number of odd terms. So that twice adjusted here would give me NC1 x raised to power 1, NC3 x cube, NC5 x raised to power 5, and so on. Now, if I go back and look at the first thing that I have, which is x raised to 1 plus x raised to power n, and this is the expansion that I have. Now, if I want sum of the binomial coefficients only in the expansion of 1 plus x raised to power n, what are the binomial coefficients? NC0, NC1, NC2, NC3, NC5, so on up to NCn. What I'll do is I'll put the value of x as 1 on the right hand side. What I'll get? I'll get the right hand side, which is exactly equal to this. So if I'm doing something on the right hand side, I will do the same thing on the left hand side. So if I put x is equal to 1, what I'll have? I'll have 2 raised to power n. So this is a very, very important rule that we have, which is the sum of the binomial coefficients in the expansion of 1 plus x raised to power n is 2 raised to power n. And if I take only the even or only the odd ones out, so odd and even are equal. So odd would be equal to even. If I add them up, this will be this will be half of what you have originally. So 2 raised to power n divided by 2 gives you an answer of 2 raised to power n minus 1. Now this is very, very important to remember the sum of the binomial coefficients that we have. Let's look at some of the questions related to binomial now. The first question that we have is, find the middle term in the expansion. Now I want to find the middle term in the expansion. There's actually no need for you to expand the thing and do all that stuff. What you just need to do is, the value of n is coming out to be 10. So the number of terms would be 1 more than it. That means the number of terms would be 11. Which is what? Which is odd. So I will have one middle term. There will be one middle term that you will have. And the middle term would be given by t n by 2 plus 1. So it will be t5 plus 1, which will be the sixth term. And first I'll write down the general term. Tr plus 1 for this will be given by NCR. The first term is 3x raised to power n minus r, and the second term is minus 2 raised to power r. I'll put the value of r as 5. So T6 will be equal to NC5 3x raised to power 10 minus 5, which will be 5, minus 2 raised to power again 5. So I'm just calculating it out. It is 10c5, 3x raised to power 5, and minus 2 raised to power 5. You can solve them if you want to find out the middle term. So if you expand also, if you go ahead and expand the thing, this is how it will expand. It will have 11 terms. Alternatively, you will have a plus and the you will have alternatively a plus and a minus sign here. Here it is all plus sign. Just modify this thing. You will alternatively have a plus and the minus. Sorry, it is the plus sign because this minus sign is adjusted with the powers. This minus sign is adjusted with the powers. If you open, it will have an alternatively plus and a minus sign. And the middle term, which will be the sixth term, will be equal to 10c5, 3x raised to power 5, and minus 2 raised to power 5. Let's look at another question from binomial. Find the coefficient of x raised to power 4 in the expansion of this. Now again, what I will do is write down the general term. So if I just write down the general term, it is 3x raised to power 10 minus r minus 2 raised to power r. Now what is the power that I want for x? It is x raised to power 4. So if I just look here, the power of x is 10 minus r. I'll equate it to 4. The value of r that I will get would be 6. That means it is the 7th term, which is equal to 10c6, 3x raised to power 10 minus 6, which is 4, minus 2 raised to power again 4. Sorry, minus 2 raised to power 6. So if I solve, it will be 10c6, 3 raised to power 4, minus 2 raised to power 6, which will be plus, and x raised to power 4. This will be the coefficient if you will have solved this complete thing out, this will be the coefficient of x raised to power 4 in the expansion. So it is 10c6, 3x raised to power 10 minus 6 minus 2 raised to power 6. Seventh term is the term which has x raised to power 4, and whatever is the coefficient of that term, the total coefficient would be 10c6, 3 raised to power 4 and 2 raised to power 6. You will have to actually solve the entire coefficient for the answer. It will not only be 10c6. It will be 10c6 into 3 raised to power 4 into 2 raised to power 6. Let's look at another question. Find the sum of all the coefficients in the expansion of 3x minus 2 raised to power 10. All the coefficients. If you expand it, if you go ahead and expand it, this will be the expansion that it looks like. Right? Now, I want to find the sum of all the coefficients. So if I look at it, I will get the coefficients if on the right hand side I put the value x is equal to 1. So what I'll get? 10c0, 3 raised to power 10, plus 10c1, 3 raised to power 9, 2 raised to power 1. So I'll keep on doing this thing on the right and the same thing on the left. So if I do the same thing on the left, I am left with 3 minus 2, which is 1 raised to power 10, which is what? 1. So if my right hand side is giving me sum of all the coefficients, the left hand side will give me its value. So sum of all the coefficients in the expansion of 3x plus 2 raised to power 1 is 1. Now if instead of minus it was 3x plus 2 raised to power 10, I'll simply do the same thing. I'll put x is equal to 1 on the left hand side and right hand side. Actually, there's no need for you to do the right hand side part of it. You just put it here. You'll get 3 plus 2, which is 5 raised to power 10 as your answer. So very simple question. Just put the value of all the variables equal to 1. So if there are 2 variables or 3 variables, put all of them equal to 1 and you will get your sum of all the coefficients. The other question that we have is, find the number of terms in the expansion of x plus y plus z raised to power 10. So if it was only x plus y raised to power 10, the number of terms would be 11. Because you know, if it is x plus y raised to power n, the number of terms is given by n plus 1. Here I can't do this because this is not a binomial. This is actually a case of trinomial that you have. So you cannot say the number of terms are 11. In fact, you will have to use the formula which is based upon this x1 plus x2 plus x3 so on up to x raised to power r raised to power n. So this is r terms that you have, this is n. So the number of terms are given by n plus r minus 1 cr minus 1. This is the formula that we have. So the value of n in the question is given to us as 10 and the value of r is 3. So this is 10 plus 3 minus 1 over 3 minus 1. So the value would be 12c2. If you solve the value of 12c2, which will be 12 factorial, 2 factorial and 10 factorial, which will actually be 12 into 11 by 2. So 6 into 11, which will be 66 terms that you will have in the expansion of this question, and it will not be 11, it will be in fact 66 terms that will be there in this expansion. Another question that we have, which term is independent of x in the expansion of x square plus 3 raised to power x raised to power 15? Again, I would write down the general term. In most of the questions related to binomial, the first thing that you will do will be writing down the general term, 3 raised to power x raised to power r. Now what will you do is, you will combine all the powers of x. So this will be 30 minus 2r, this will be x. I am just looking at the value of exponents of x and not something else. When the bases are same, the powers are added. So it will be x minus 2r minus r, so it will be x minus 30 minus 3r. Now I want the term to be independent of x. That means this value of the power of the exponent should come out to be 0. That means 30 is equal to 3r, or the value of r should come out to be 10. So if the value of r is 10, it is the tr plus 1 term or 11th term. Which term is independent? 11th term is independent of x in the expansion of x square plus 3 by x raised to power 15. There will be total of 16 terms and 11th term will be independent of x. I hope you have understood binomial by now. Thank you so much for watching the video. For more practice questions on binomial, please refer to our website edusathi.com. Have a good day.